Hi, my name is Patrick Reagan. Part 2, Introduction to the OSI Model video, will define the OSI model and give you an overview of the 7 layers of the OSI model. It will discuss how data is encapsulated before it's sent on the network and decapsulated when it gets to the destination. The Open Systems Interconnection, or OSI model, is a theoretical model that is more descriptive and detailed, which is used as a guide for understanding network interactions. The conceptual model was created by the International Organization for Standardization to enable diverse communication systems to communicate using standard protocols. It provides a standard for different computer systems to be able to communicate with each other. It is based on the concept of splitting up communication systems into 7 abstract layers, each one stacked upon the last. The bottom layer is the physical layer that handles the physical signaling, including connectors, timing, voltages, and other matters where the data is sent in a stream of bits. The second layer is the data link layer, which is responsible for the transfer of data over the channel. The third layer is the network layer, which is responsible for addressing and routing between subnetworks. The fourth layer is the transport layer that ensures end-to-end error-free delivery. The fifth layer is the session layer that performs administrative tasks and security. The sixth layer is the presentation layer, which provides for the representation of the data. The top layer is the application layer, which is concerned with the support of end-user application processes. This is the network services that are being provided. Don't get hung up on the details of the OSI model, but it is a way to organize the various technologies used in networking. It is used to create a universal set of standards for network communications. It enables different networking requirements and software from various vendors to work together. It divides network communications into manageable layers, each with specific functions. It provides a clear framework for the development and implementation of networking technologies. It simplifies the process of diagnosing and resolving network issues. It is used to classify communication technologies and systems into 7 abstract layers. It provides a comprehensive framework for teaching and understanding network concepts. To help remember the order of the OSI models is to use mnemonics where the first letter of each word of the mnemonic represents the first letter of the layer. 2 common mnemonics used is, please do not throw sausage pizza away, and please do not take salespeople's advice. The P layer, or layer 1, is the physical layer that transmits raw bits over the physical medium, including wireless. It includes the signaling, cables, connectors, hubs, and repeaters. The D layer is the data link layer, which defines the format of data on the network, how a device gets access to the network, and includes the physical addressing or media access control, or MAC address. In the data link layer, the data is grouped into frames. It includes the IEEE 802.2 or Ethernet standard, the ARP protocol, and bridges and switches. The N layer is the network layer, which is where routing occurs that decide which physical path the data will take to get from one network to another. It includes the logical addresses such as IP addressing. The network layer is the IP and ICMP protocols, routers, and packet filtering based on IP addressing. The data unit used in network layers is packets. The T layer is the transport layer, which is the end-to-end connection and reliability transmission protocols, including TCP and UDP. TCP protocol is connection-oriented, which uses acknowledgments, and UDP, which is connectionless connections, which does not use acknowledgments when sending data. The session layer data units is segments. Notice that the data units for the first 4 layers is bits, frames, packets, and segments, which are alphabetical. The S layer is the session layer, which maintains connections and is responsible for controlling ports and sessions. A socket is a virtual endpoint that acts as a communication channel between 2 applications on different devices, allowing them to send and receive data across a network. It essentially a logical address that combines an IP address and a port number to uniquely identify a specific application on a host. That enables data transfers between applications on different machines. The P layer is the presentation layer, which ensures that data is in a usable format or syntax and is where encryption occurs. Examples include SSL/TLS, SSH, IMAP, ASCII, and PGP. The A layer is the application layer, is the interfaces to the network services. It includes HTTP, FTP, DNS, DHCP, SMTP, SNMP, and Telnet. In the OSI model, Layer 1 and Layer 2 are considered hardware dependent because they directly interact with the physical network components like cables, connectors, and network interface cards, defining how raw data is transmitted as electrical signals over the medium. While the upper layers deal with logical functions and data manipulation, making them independent of the specific hardware used to transmit the data. When a network service or application has data that needs to be sent, the data is encapsulated as it goes down from the top layer to the bottom layer. Encapsulation adds information to the data as it travels to the bottom layer. When the data gets to the destination machine, decapsulation reverses the process that removes the information as it moves to the upper layers. As you can see from this slide, data is generated by the application or network service, which is formatted in a usable format. As the data moves down to the transport layer, the data is broken into smaller pieces called segments, and a segment header is added so that the pieces can be reassembled at the receiving end. As the data moves down to the network layer, a packet header is added where it includes information needed for logical addressing, such as IP address and routing. As the data moves down to the data link layer, a frame header and trailer is added, which is needed for switching based on physical addresses or MAC addresses and to detect and drop corrupt data. The data is converted to signals or bits, which is transmitted over a wire or wireless medium to the receiving computer. The process is reversed where the bits are converted and sent to the data link layer where the frame header and trailer is removed. When it reaches the network layer, the packet header is removed. The segments are put back together in the correct order and the segment header is removed. You are then left with the data payload. The data payload is then processed by the application or network service. This slide shows the information that's being added or removed as the data is getting encapsulated or decapsulated. The data link layer will add the physical address information and error control, which is used to move data between two computers or endpoints on the same network. The network layer has the logical addressing information including IP address and is used to move data between networks. The transport layer includes flow control, sequencing, and overall error checking information. Question: what is the conceptual model that's used to classify communication technologies and systems into 7 abstract layers? Answer: OSI model. Question: what is between the session layer and the data link layer? Choose 2 answers. Answer: transport layer and network layer. Question: what is the lowest level of the OSI model? Answer: physical. Question: what is the highest level of the OSI model? Answer: application. Question: what do you call the process that adds information to a data payload as it goes down through the OSI model before it is sent to its destination? Answer: encapsulation. For more information, refer to these sites. In summary, the Open Systems Interconnection, or OSI model, is a conceptual model created by the International Organization for Standardization, which enables diverse communication systems to communicate using standard protocols. The OSI model provides a standard for different computer systems to be able to communicate with each other. It's based on the concept of splitting up the communication systems into 7 abstract layers, each one stacked upon the last. It divides the network communications into manageable layers, each with a specific function. It's used to classify communications technologies and systems into 7 abstract layers. It provides a comprehensive framework for teaching and understanding network concepts. It simplifies the process of diagnosing and resolving network issues. Encapsulation adds information to a packet as it travels to its destination. Thank you for watching this video. The next video will be the OSI model lower layers. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.